Welcome to Algebra 2, Unit 6, Lessons 7 and 8 practice problems. The center of a clock is at 0, 0 in a coordinate system, and the minute hand is 10 inches long. Find the approximate coordinates of the tip of the minute hand at these three times. So to help out with this, we have a clock. Now, as we think about this, remember that we always start from the positive x-axis when we are talking about angles. So for number 1, we're talking about the minute hand when it's 12:05. So we have the minute hand going out to the 1, and we're talking about this angle right here in red. Well, this angle would be pi over 3 because half the circle would be pi. So from the 3 to the 1 would be a third of that pi. So when we're looking for the coordinates, remember that our coordinates are always x, y. But now we're talking about trig, so our coordinates are going to be cosine, and our angle is pi over 3. And then our y is going to be sine of pi over 3. And then you can turn this into actual decimal coordinates. One important thing is to make sure that your calculator is in radians. Okay, it'll probably default start on degrees, so you want to make sure that you change it to radians. That way it understands the trig angles. So now to find cosine, we're going to do in parentheses pi divided by 3, close the parentheses, and then we want the cosine. Well, the cosine is 0.5. And then we'll do the same thing to find sine. We'll have pi divided by 3, but this time we want the sine. And that's approximately 0.87. But when we're doing it this way, we're thinking about a unit circle. And on a unit circle, the radius is always 1. But now we know that the minute hand is 10 inches long. So now what we need to do is actually take these and multiply them by 10. So now what we really want to do is have our coordinates be 10 cosine of pi over 3 and 10 sine of pi over 3. So now in my calculator, I could say pi divided by 3 cosine. Now I want to take that and multiply it by 10. So my x coordinate is going to be 5. Now I go in and I do the same thing for the y. I've got pi divided by 3, but this time I want the sine, and then I'm going to take this value and multiply it by 10, and I get approximately 8.7. So the coordinates for the tip of the minute hand when the radius is 10 and the time is 12:05 would be x equals 5, y equals 8.7. So now let's try this for the next one. Now we're looking at 12:45. So our minute hand would be straight over here at the 9. And our angle would be pi. So now we have 10 times the cosine of pi, 10 times sine of pi. Well, for this one, cosine is our x value. And we know that our x value at pi is -1, but now we're multiplying that by 10. So we have -10 for the x value. And our sine value is our y value. But our y value at pi is 0. And 10 times 0 would be 0. So at 12:45, the coordinates for the tip of the hand would be -10, 0. And number 3, we want the tip of the minute hand when it's 12:55. The minute hand would be pointed at the 11, and our angle would now be 2 pi over 3 because we are 2/3 of the way to pi. If our angle is 2 pi over 3, then we're going to do the same thing we did in the first two. We're going to multiply by 10 because the minute hand is 10 inches long. And we'll want the cosine of 2 pi over 3. And we'll want 10 times the sine of 2 pi over 3. So in a calculator, I can say 2 times pi divided by 3, and that I want the cosine of that. Now I'm going to multiply that by 10, and I get negative 5. Then I want the y value. So again, in parentheses, 2 times pi divided by 3. And now I want the sine of that, and I want to multiply it by 10. And I have 8.7. If you notice, the only difference between the answers for 1 and 3 is whether the x-coordinate is positive or negative. Because pi over 3 and 2 pi over 3 are forming the same angle with the x-axis. So our y values are going to be the same, but the x value in quadrant 1 is going to be positive, and the x value in quadrant 2 is going to be negative. And all we did, since we, instead of using a unit circle, we're using a radius of 10, we just simply multiplied cosine and sine by 10. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. The center of a Ferris wheel is 100 feet off the ground, and its radius is 85 feet. The point A is at the 0 radian position. B is rotated 7 pi over 12 radians from A, and C is rotated 5 pi over 4 radians from A. For each point A, B, and C, find how high the position is on the Ferris wheel from the ground. Write an expression using the sine or cosine function and estimate the value. So because we want height off the ground, the only thing we care about is the y value. So we are only going to use sine and not cosine. So for A, this is going to equal 100 feet to the center point plus 85, which is the radius, times the sine of 0. So in a calculator, we would say 0, we want the sine, and we want to multiply that by 85, which is 0. And 100 plus 0 is 0. And if you think about this, remember, sine is your y distance. Well, if I'm over here at A, then I have an x value, but I'm on the x-axis, so my y value is 0. So we're not actually adding any height to the center. For point B, again, we're going to have the 100 which represents the height to the center of the circle. Then we're going to add 85 as the radius times the sine. This time, b is at 7 pi over 12 radians. So in the calculator, we're going to do 7 times pi divided by 12, and we want the sine. And now we're going to multiply that by 85. And we get approximately 82.1. And now we add that to 100, and we get 182.1. And I just noticed I wrote this down wrong on point A. 100 plus 0 is 100, not 0. So far we have found that point A is going to be 100 feet above the ground. And we have found that point B is going to be 182 feet above the ground. And finally, point C. We start with the 100 feet to the center of the circle, plus 85, which is the radius, times sine of 5 pi over 4. Now, in a calculator, we can do parentheses 5 times pi divided by 4, close parentheses, and now we want the sine of that. And we get negative 0.7. Now we multiply that by 85, and we get negative 60. So instead of adding, we are subtracting 60 feet. And 100 minus 60 is 40. So the height of A is in line with the center, so it is also 100 feet above the ground. Point B is near the top of the circle, so it's not quite an additional 85, it's actually 182 feet above. And then we can see that point C is down below that 100-foot center. It's actually 40 feet above the ground. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. A Ferris wheel has a radius of 50 feet and its center is 60 feet off the ground. How many points on the Ferris wheel are, number 1, 30 feet off the ground? So we could draw our Ferris wheel. And we know that the center is 60 and that it has a radius of 50. And number 1 wants to know how many points there are 30 feet off the ground. Well, 30 feet off the ground would be halfway up the Ferris wheel. And since there's a 50-foot radius, the bottom of the Ferris wheel is going to be at 10 feet. So we're going to have a point in quadrant 4 that's 30 feet. And we're going to have a point in quadrant 3 that is also 30 feet. So there are 2 points. Number 2 wants to know how many points are 110 feet off the ground. Well, it's 60 feet to the center, and it's another 50 feet to the top. 60 plus 50 is 110. So there is 1 point at the very top that is 110 feet. So only 1 point is 110 feet off the ground. And number 3, how many points are 5 feet off the ground? Well, we said it was 60 feet to the center, and the radius is 50. So the bottom of the Ferris wheel is 10 feet off the ground. That means 5 feet is halfway to the bottom of the Ferris wheel, so it is not even on the Ferris wheel. So that would be 0 points. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. The minute hand on a clock tower is 6 feet long. At 10 minutes after the hour, the tip of the minute hand is 55 feet above the ground. How high above the ground is the center of the clock face? Explain how you know. So if we had a clock face, and we put the numbers on here, if we are talking about 10 minutes, then the hand is pointing at the 2, so we have this angle in red. Since we're talking about the height, we want the sine because that is the y value. So at this angle, we have pi over 6 because pi would be from 3 around to 9. So this would be one of 6 places to get over there. But since it's 6 feet long, we're going to say 6 times the sine of pi over 6, and we can put this in the calculator. So we would say in parentheses, pi divided by 6, close parentheses, and we want the sine, which is 1/2, times the 6-foot length of the clock hand, which is 3. So the clock hand is 3 feet above center. So if the tip of the hand is 55 feet above the ground, minus the 3 feet that it is above the center, that tells us the center is 52 feet above the ground. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. A fan blade spins counterclockwise once per second. Which of these graphs best depicts the height h of P after s seconds? The fan blades are 1 foot long and the height is measured in feet from the center of the fan blade. So as we look at these, you can see height is the y-axis and seconds is the x-axis. And what we see is that the fan blade spins counterclockwise once per second. So at this point right here, my y value is 0. So at 0 seconds, my height is 0. Now it's going to rotate counterclockwise, and at 1/4 second, my height is going to be 1. Then it's going to continue rotating counterclockwise, and at 1/2 second, the height is 0 again. Then we rotate down, and at 3/4 of a second, height is -1. And then it continues rotating until it's back to the starting point, where at 1 second, the height is 0. So as we look through the choices, A is wrong because it shows 2 full rotations. B is incorrect because it shows it go from 0 height to -1. So this is rotating clockwise. C also starts at 0 and goes down to -1 first, and it completes 2 full rotations. So this rotates clockwise twice. The correct depiction is D. We have the starting point. This is where it hits the top of the fan. This is where it rotates around to the left. This is where it hits the bottom of the fan. And then here it returns to the starting position. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Which situations are modeled accurately by a periodic function. Select all that apply. So the key here is that this is a periodic function. And periodic means repeating. So it doesn't just happen once, it doesn't happen in a continual manner, it repeats. Just like we've been looking at Ferris wheels and clocks, we're looking for functions that repeat their values over and over again. So A, the distance from the Earth to the Sun as a function of time. The Earth revolves around the Sun, and so the distance between the two is on this repeating pathway. So that is a periodic function. Choice B, the vertical height of a point on a rotating wheel as a function of time. So if you picked any point on a wheel, such as the air stem valve, that point is going to go around and around and around and repeat the same height over and over. It'll be at the bottom, then halfway, then at the top, then back to halfway, back down to the bottom, over and over again. So B is a repeating or periodic function. Choice C, the area of a sheet of paper as a function of the number of times it is folded in half. This is going to be exponential decay. This does not repeat itself. It starts at one size and it only gets smaller and smaller and smaller. Therefore, it is not a periodic function. Choice D, the number of centimeters in x inches. This is going to be a linear increase. Every time we add an inch, we will add 2.56 centimeters. It will continue to increase in a straight line forever. So that is not a periodic function. Choice E, the height of a swinging pendulum as a function of time. If I pull a pendulum back, it will start at that height, it'll swing down to the bottom at the center, then it'll swing back up on the opposite side, then it will swing back down again to the bottom in the center, and then back up towards the top. While it will never reach the same maximum height again, it will constantly repeat those lower heights. We call this harmonic oscillation, and that is a periodic function. And the final choice is choice F, the height of a ball tossed in the air as a function of time. The ball will start at the ground, it will go up to its maximum height, and then it will come back down. But that will only happen once. This is not a periodic function, this is a quadratic function. So the correct choices on this one are A, B, and E. If you have any questions about how I solved this practice problem, Please use class time to ask for further clarification. Here's the graph of a function for some values of x. Number 1, can you extend the graph to the whole plane so that the function f is periodic? Explain your reasoning. We could. We see that it starts at 1, goes up to 2 as we start from x equals 0 and go to 1. We could repeat this in a downward position to 2, 1, and then back up again to 3, 2. We could also have this repeating going to the left, where it would be at negative 1, 2, then down to negative 2, 1, and up to negative 3, 2. This would be a periodic function. Number 2, can you extend the graph to the whole plane so that the function of f is not periodic? Explain your reasoning. I could have an absolute value function that has been shifted left to have the vertex at negative 1, 0. Then we would have a V shape that continued throughout the entire plane. And would not be a repeating or periodic function. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Number 1, can a non-constant linear function be periodic? Explain your reasoning. For number 1, no. A linear function either increases forever or decreases forever between a set of domain. It could never increase and decrease and increase and decrease to form a periodic function. In a certain set of domain, it is only increasing or decreasing. Number 2, can a quadratic function be periodic? Explain your reasoning. Again, no, it cannot. A quadratic function increases or decreases until it reaches the vertex then does the opposite. It never repeats. So a quadratic function is one that has a parabola. It either increases to the vertex and then decreases, or it decreases until the vertex and then increases. It never repeats, so it cannot be a periodic function. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. The center of a clock is the origin, 0, 0, in a coordinate system. The hour hand is 4 units long. What are the coordinates of the end of the hour hand at these 3 times? So, if we draw our clock so that we have a reference, we need to keep in mind that the hour hand is 4 units long. So we will approach it like a unit circle, but multiply by 4. So at 3 o'clock, the hour hand is along the x-axis. So when we think about this, we have 4 times the cosine of 0, and we have 4 times the sine of 0. The cosine of 0 is 1 because the cosine is the x value. So if I went straight out to the x value on the unit circle, it would be 1. Now 4 times 1 would be 4. The sine of 0, which is the y value when we are at x equals 1, is 0. And 4 times 0 is 0. So the coordinates at 3 o'clock would be 4, 0. Next, we're looking at 8 o'clock. So now we're pointing down here. We have a full pi and then one more sixth. So this is going to be 7/6 pi. So we have 4 times the cosine of 7/6 pi and 4 times sine of 7/6 pi. So on this one, I'm going to use a calculator. We have parentheses 7 times pi divided by 6, close parentheses. We want the cosine of that, and then we want to multiply that by 4. And we have negative 3.5. Next, we have parentheses 7 times pi divided by 6, close parentheses. Now we want the sine of that, and we want to multiply that by 4. And our answer is negative 2. And this makes sense because we have a negative x and a negative y, and we are in quadrant 3 where we have negative x and negative y values. And number 3, we're now talking about 11 o'clock. So at 11 o'clock, we're going to use 4 times the cosine. This would be 2/3 pi, and 4 times sine of 2/3 pi. Now we can use the calculator. Parentheses, 2 times pi divided by 3, close parentheses. We want the cosine. And now we're going to multiply by 4. And we get -2. Now, parentheses, 2 times pi divided by 3, close parentheses. We want the sine, and then we're going to multiply by 4. And we get 3.5. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Using a unit circle display, give an example of an angle satisfying each inequality. So if we draw a unit circle, A wants cosine to be greater than 0. This means we need a positive x. And they want sine to be less than 0. That means we need a negative y. To have a positive x and a negative y, we need to be in quadrant 4. And an example of a point that we could put over here is 7/4 pi. Because 4/4 would take us around halfway, and then we'd have another 3/4. So this angle would work for A. Number 2, they want B to have a cosine that is less than 0. That means we need a negative x, and they want sine to be greater than 0. That means we need a positive y. If I want a negative x and a positive y, I'm in quadrant 2. So we could draw this angle here, in which we would say this is 3/4 of pi. So 3/4 pi would work for number 2. And number 3, they want C so that cosine is less than 0. That means they want a negative x, and they want sine to be less than 0. That means they want a negative y. If I need a negative x and a negative y, then I am in quadrant 3. We can draw this angle. 4/4 would take us halfway, so this would be 5/4 pi. If you have any questions about how I solved this practice problem, please use class time to ask for further clarification. Our last practice problem for lessons 7 and 8 in Unit 6. Suppose angle theta in radians is in quadrant 3 of the unit circle. If sine theta equals negative 0.45, what are the values of cosine theta and tangent theta? So this is where we need to use the Pythagorean identity. We know that sine squared theta plus cosine squared theta equals 1 squared in a unit circle. So now I know that sine is negative 0.45. I need to find cosine squared. So in a calculator, 0.45 squared is 0.2025. And we know that 1 squared is 1. So now I'm going to subtract 0.2025 from both sides. And I know that cosine squared equals 1 minus 0.2025, which is 0.7975. Now I need to take the square root of both sides. So cosine equals the square root of 0.7975, and that is 0.89. One thing we want to keep in mind is that if we are in quadrant 3, then both sine and cosine are going to be negative. So in Q3, cosine equals negative 0.89. Now tangent of theta equals sine divided by cosine. So we said that sine was negative 0.45, and we just said that cosine was 0.89. So when we put that in a calculator, 0.45 negative divided by 0.89 negative equals 0.51. If you have any questions about how I solved this practice problem or any other practice problems from this lesson, please use class time now to ask for further clarification.